Go ahead.
Hi, everyone. Sorry I could not be there in person, but I'm really excited to present this work. My name is Harry. I'm a PhD candidate at the University of Pennsylvania, and I'm presenting some problems with properties, an interview study on property-based testing. This is work with myself, Joseph Cutler, Adam Stein, Andrew Head, and my advisor, Benjamin Pierce. So I think many of you all, dream about property-based testing when I'm asleep, right? It's a lovely thing. It's the topic of my dissertation. It's a thing I love very much. And, but a few months ago, I started to be awoken by an unsettling question. How do I know that the work that I'm doing with property-based testing is actually going to impact real people? How do I know that the developers that are using property-based testing in industry are actually going to be able to use the things we build as programming languages researchers? And luckily, at around the time that I was starting to worry about this, there was a new human-computer interaction group at Penn starting up with Denai Metaxa and Andrew Head, as pictured here. And Andrew was excited to work with the PL group, and we were excited to work with him. So I asked, can we use the tools of HCI to start to answer this question, to start to figure out if the PL work that we're doing, if the property-based testing work we're doing will actually help real people? And he said yes, and we've been collaborating since, and that is what I'm going to tell you about today. So to kind of orient where we're going, I'll start by talking about what is property-based testing, if you've never heard of it, if you don't dream about it like I do. Then I'll tell you about a preliminary interview study that we did. I'll tell you about a full-scale study that is currently ongoing, and then some ideas for the future. So what is property-based testing? Suppose you have a very important program that you need to make sure is correct. You can do the standard formal methods thing and write some specification for this program. In this case, it's universally quantified over some inputs and says that as long as the input satisfies the precondition, then some postcondition holds when I call the program. In property-based testing, rather than, unlike in formal methods where we would prove this property, in property-based testing, we randomly generate lots of inputs to the property, and we check that the property holds for each one of those inputs. And this way, we gain confidence that the property holds without having to go to all the trouble of proving it. So this is kind of the high-level view of property-based testing. You write executable properties, and you test them with lots and lots of random inputs. In the past, my research focus and a lot of the focus of the property-based testing community has been on improving the effectiveness of these tools and improving random data generation in particular so that we can exercise the properties as well as possible. But this has the problem that I alluded to before, where it wasn't 100% clear that even as we were improving on benchmarks and improving the way generators work, that the software engineers using property-based testing were going to benefit from this work. And so we've broadened our focus a little bit. And now I'm asking the question, how can the research community make the property-based testing more useful for real-world software engineers in general? And then hopefully the work we were doing with generators is actually going to apply, is actually going to be useful. But I wanted to kind of ground the work in what the software engineers are actually doing. So that is how we get to this preliminary interview study that we did. We interviewed 7 software developers about their use of property-based testing. They were 30-minute interviews, and we just asked them about their experience using it. We had 7 participants, like I said. They were a bit overeducated on average because we just recruited through Twitter, so we got a lot of people with PhDs because we follow a lot of people with PhDs. But they did have a pretty wide range of experience using property-based testing, between 8 years and less than 1. when we actually spoke with folks, we had a few prompts that we asked them. We first started by asking them to tell us about a memorable experience applying property-based testing. This was important because if you ask users in a study like this to tell you something without kind of grounding it in a specific experience, they may kind of accidentally lie to you and tell you things that feel true or that seem like they should be true, rather than, the truth of an actual situation. Then, once we had them talking about something specific, we asked them about their properties and their generators to try to focus the conversation on what we saw as the two main pillars of property-based testing. I'm sure everyone here knows this, but I'm going to go through it just in case. We did a thematic analysis of the transcripts that we got back. I had never done this before, so it was really interesting to me. In order to get the information we wanted out of the transcripts, we found some really interesting parts. We found the parts that seemed to evoke something that we wanted to capture. And then we categorized them into themes, and those themes became the kind of main result of the study. It was the themes that point to the things we wanted to learn about property-based testing in industry. So we had 5 main themes that came out of the study. I'll talk about each of them in a little bit of detail, and then we'll come back to what all of this really means. So first, the folks we spoke with did in fact have issues with designing generators. This was quite comforting to me. It meant that a lot of the work I had been doing was actually useful to folks in industry. But the specifics of exactly what we found was interesting. So first, and unsurprisingly, one of the main things that folks struggled with was properties with non-trivial preconditions. When a property has a tricky precondition, the generators aren't good at generating things that satisfy the precondition, and then the property never actually gets exercised. This happens, this is like a kind of core problem of the property-based testing research literature, and is well represented in the problems of the folks that we spoke with. Other problems for generators included things like distributional issues. So their generators weren't necessarily getting all of the useful use cases or weren't getting them often enough. And also, they pointed out that there are kind of weird languages that some of these frameworks provide for defining the generators. And in some languages, the DSLs for writing generators weren't as idiomatic as our participants were expecting. And so that's another thing to watch out for, is that the language design here is really important. On the topic of properties, our participants had trouble sometimes just finding any property at all to test. This led them often to test very weak properties. So properties that are kind of uninteresting. For example, the code doesn't crash is a kind of uninteresting property. It's fine to do that to test in that way, but it's just much more interesting and useful when you're testing more richer properties. Another issue that our participants ran into was poorly abstracted code. This is well known in general that for testing, it's hard to test code that is poorly abstracted. It's hard to test spaghetti code. But property-based testing seems to be particularly sensitive to this problem, because you need the code to also not have effects in certain ways and things like that. So the just kind of finding the properties in a mess of code was really challenging. And then another thing on the topic of properties was not so much a challenge, but just a really interesting use case is model-based testing. So in model-based property-based testing, rather than write a kind of precondition, post-condition property like I had on the last slide, they write a model implementation of their code, and then they test that the model implementation agrees with the code that they wrote. This is a totally legit way of doing property-based testing, but it's not necessarily one that the literature supports in the same way as the standard logical properties. And so we think that there's probably an opportunity here to better support model-based testing because so many of the people we spoke with were doing this kind of property-based testing. Another theme is around the programmer workflow when using property-based testing. Property-based testing is a kind of annoying combination of non-deterministic and long-running, which caused problems for our participants. So some of our participants only ran their properties locally. They didn't want to put their property-based tests in continuous integration because they were worried that putting it in continuous integration would lead to them being woken up in the middle of the night by a failing test that just randomly failed in CI. On the other hand, some of our participants only ran their property-based tests on CI because they were worried that it would just take too long to run them locally. This kind of tension is something that we think tools should be able to fix. And so we were excited to be able to identify this and start to think about solutions. There are two more main kind of categories of themes. One is education. So it's not surprising that education around property-based testing is an issue. It's not in standard CS curricula. It's not really something that people have always seen. And so it was just kind of foreign to developers, and the participants were saying, besides just formal education, also documentation seemed to be lacking, examples seemed to be lacking. All of this was a very strong theme that we heard, is that people just wanted better ways to kind of get into the property-based testing world. And then another problem in a similar vein is bootstrapping. So when property-based testing isn't used at a particular organization, it's unlikely for it to start being used at that organization. And this is unsurprising, but it's important to point out because it's a social problem that we can't really solve with research, but that is a real barrier to property-based testing's adoption in industry. And so it's a thing that we need to keep in mind when working with people in industry, because this is a real problem that, there's real reasons that bootstrapping problems exist in software, and we should be aware of that. So these are the 5 themes that we came up with from the 7 participants we talked to. But as I said, there were only 7 participants. So what are we missing, right? What else is there that we haven't found yet? What parts of these themes that we've already identified are kind of slightly wrong? We needed to scale this up if we were actually going to find out what's going on. And so now I'm going to describe an ongoing study that does just that. So we've partnered with Jane Street. Jane Street is a financial technology firm that is pretty kind of closely tied to the functional programming community. They use OCaml almost exclusively, which is really good because property-based testing kind of grew up in the FP community. So Jane Street developers have often heard of or used property-based testing before. We have currently interviewed, actually, this looks like 27, but it's actually 29. We've interviewed 29 of the 30 total developers that we intend to interview. And we scaled up the interview time as well. In the preliminary study, we were talking to them for 30 minutes, but now we're talking to them for about an hour. And the whole goal of this is, again, to refine our understanding of the themes from the preliminary study and to come up with some new ones. We have some new research questions that are, again, refined by the preliminary study. So we're now not just asking about properties and generators, but we're really trying to dig into the specifics of how people come up with the properties, the generators, and the workflow and the concrete changes that people actually at Jane Street want to see in their property-based testing systems. We've really broadened our focus and tried to refine our understanding based on what we already learned. So let's look back at our themes from the preliminary study and see, so far, this is very preliminary because we haven't really, even though we've interviewed 29 people so far, we haven't done any formal analysis yet, but we've done some preliminary analysis, and I can start to hint at how I think these things are changing. So one thing is the property design. So in the preliminary study, the signal was, I don't know how to write properties for the program that I want to test. And at Jane Street, they don't seem to have that problem in the same way. And we suspect because they think of this as more of a task of property recognition than actually property design. What do I mean by that? I mean that at Jane Street, the developers seem to be more opportunistic, applying property-based testing when it's readily applicable and avoiding it when it seems too difficult or too time-consuming to find the right properties for a particular system. This is potentially a little unsatisfying from a research perspective because we want to keep adding new and better ways for them to write properties about the places where it's hard. But from an education and adoption perspective, framing things in terms of property recognition means that we can really pull together a list of the best times to use property-based testing. And as long as those are kind of generally applicable and things that people actually run into, that's a thing that we can tell people about to get them more excited about property-based testing. When it comes to generator design, that was absolutely still a theme of the Jane Street study, but we've added automation to the picture. The Jane Street developers use a lot of automation in their property-based testing, and we think that some of the tools that they use should be available more broadly, and that the tools that they use also can be improved by research. And finally, a new theme has emerged regarding evaluation. We've started to ask people about how they know that the generators and properties they write are actually testing what they want to test and are actually exercising their code in the way they hope. And the answer is usually that they're not sure and that they'd like better tools to tell them how well they're doing, how well their generators covering the space, etc. So evaluation, I think, is going to be a really exciting new theme from this study, and one that I'm excited to do some work on moving forward. Speaking of moving forward, let me talk to you a little bit about some ideas for the future. First, we want to do surveys or something else to validate the results of the study with Jane Street. Jane Street is, I think, a really good place to do this first study, but it is only one company. It's a limited population, so we want to make sure that the things we're learning are generalized beyond just this one context. Another thing we want to do is potentially more formative research into property-based testing usage. One thing that Andrew's really excited about is trying to figure out what the maximum possible impact for property-based testing is. Like, how far could this go? What percentage of software developers could potentially be using property-based testing? Another thing we want to do is prototype tools to actually help with the challenges that we've been thinking about, and try to improve the state of affairs. And finally, we want to develop better educational curricula, examples, and documentation around property-based testing so that people have an easier time getting into it. That is what I have. I'd love feedback. So on study design, on questions, on ways to make this just more compelling to PL and HCI audiences. And then I have put my contact information right under my captions, but you can find me through AirMeet, and I would love to chat now and throughout the rest of the day.
All right, let's give Harry a round of applause. All right, so do we have questions in person?
Right. Hello. So yeah, that's very interesting. I've been thinking about a similar question in a different context, and so maybe I don't like talking to people, or maybe I don't believe what people say. But what about looking at artifacts in addition to talking to people, right?
You mean artifacts like property-based tests in the wild and on GitHub and things like that?
Yeah, or in like there's on GitHub, but then there's also in James Pete's repositories, right?
Yeah. So that's a yes, absolutely. So when it came to we've absolutely considered that, and this is a thing that is a totally legitimate approach. We haven't done it mostly because the particulars of the legal loopholes we were jumping through to get started with Jane Street were such that it was easier if we didn't have to look at code the first round through. And then also we had better ideas initially for how we wanted to run interviews versus what we would do if we had our hands on the code. But yes, that's totally another avenue that is a good one to take.
Yeah, I think it'd be super interesting to see if these cross-check, right? Like people say X, people do X, or people do Y, and is X and Y equal?
Yeah, for sure.
Yeah.
Hi, thanks for the talk. I think this is really interesting. I had a question because I was surprised when you said people have problems with non-determinism in CI builds. So I would have expected maybe setting a consistent seed or something so that even if there's like arbitrary values coming out, it would still be consistent. So is that not something people do? Is that not a best practice? Do people like to not have a consistent seed? Or?
So that's a thing. It's a little controversial. So at Jane Street, that's pretty consistent. That's what they do is when they put their properties in CI, they set the seed. The reason it's a little controversial is because it feels like then you're kind of really limiting the effectiveness of that property in CI. Like some of the beauty of it is that it keeps running and keeps being able to find the bug. So I don't know. I think that this is philosophically a kind of a challenging question, whether that's a thing the library wants to provide or not. Because if you do provide the ability to just fix the seed in CI, you're implicitly giving something up in terms of the kind of long-term ability to surreptitiously find bugs.
Okay, thanks.
Okay, let's actually do one remote question, and then we can hopefully come back in a few minutes. I think Michael, can you unmute and ask your question?
Yeah, neat talk. Thank you. I kind of have a suggestion for your upcoming work. I'm hoping you can uncover some insight about language design. So, of course, you focus on OCaml here, and that's a good place to start. But I wonder, what we can learn about this in other language contexts. Should we, stop using Java because Java is somehow anti-property-based testing, or is actually property-based testing great in Java, or et cetera, et cetera?
Yeah, this is a really good question. I to some extent we've been avoiding very language specific things because in a lot of ways the language is orthogonal to the property based testing. Like yes, it impacts the property based testing, but the conclusions one would draw are similar to the kind of dogmatic conclusions one might draw in any cursory analysis of when languages are better than other languages. The part that's been really interesting, though, is the places where We have noticed really interesting. So the bulk of the preliminary study users were using Python, and the Jane Street users use OCaml. And we have found some interesting places where, for example, types in OCaml are helping the OCaml devs in a way that the types aren't helping the Python developers. But I guess it just feels like all of these conclusions are ones that could be drawn without property-based testing in the mix, and are like minefields that I don't necessarily want to wade into.
Yeah, there could be some aspects of convenience, like maybe languages with better metaprogramming facilities would make it easier to write general purpose generators.
Yes. Yeah, that's for sure. The Jane Street folks are making really good use of that. It's not clear what that kind of thing looks like in Python because it doesn't have the same metaprogramming facilities. Yeah, I mean, yes, language design is absolutely a thing here. It's just a question of whether property-based testing is the argument that's going to get someone to switch or to redesign their language.
Yep. Okay, thanks.
Okay, it is 10 o'clock, so I want to make sure people get to go to the break. So let's give everyone more round of applause.
Thanks, everyone.